Now that we know how sine, cosine, and tangent relate to the sides of a triangle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, we can use this information to solve for these things in different problems. So here's an example right here. This is a surveyor, and he has figured out that the angle of elevation between him and the top of a building is 22 degrees. So you can see that represented right here. That's called the angle of elevation. That's how high up we're going. Angle of elevation. Now he already knows that he is 300 feet from the edge of the building, and he wants to use that information to find the height of the building. Now this may seem like a silly example, but surveyors really do use geometry-related things to find out things like how an elevation changes from one hill to the next, or one part of town to the next, or the height of a hill or the height of a mountain, and different things like that. So this really is used when it comes to surveying and people who do natural geography type things. So here's what we have to do. We have an angle, 22 degrees, and let's label these sides. We know this is the hypotenuse, we know this is the adjacent, and we know this is the opposite. Well, we know the adjacent angle, and we want, the adjacent side, and we want to know the opposite side. So you have to think, which of your trig functions, and we'll just stick with sine, cosine, and tangent for this, involve the opposite and the adjacent? Well, that would be tangent. So we can set this up and we can say, okay, the tangent of 22 degrees, because that's my angle, has to equal the opposite side, x, over the adjacent side, 300. Okay, now I need to solve for x. So to do that, I simply multiply both sides by 300. So I get x equals 300 times tangent of 22 degrees. So let's pull up the calculator. We need to change our mode to degrees, if it's not already. Here we go. And we do 300 times tangent of 22 degrees. So it turns out the height of that building is 121.207 feet, or 208. So just using an angle and the length of from someone to the building, they can figure out the height of the building. Okay, let's try another one. Oops, sorry about that. So now we've got this picture. We've got someone riding a bicycle, at least I think that's what that's supposed to be. And he knows the length of the ramp he's about to ride up is 100 feet, but he wants to know how high this ramp is before he decides to ride it. And he's figured out that the angle is 24 degrees. Must have had a protractor in his back pocket, lucky him. So let's plug this in again. Let's label the sides. This is the adjacent, this is the opposite, and this is the hypotenuse. So this time we know the hypotenuse, 100 feet, and we want to know the opposite. So you need to think, what trig function relates the opposite and hypotenuse? Well, that would be sine. So we can set this up and say sine of 24 degrees is equal to the opposite over the hypotenuse, which is 100. So to solve for x, multiply both sides by 100. So we know x is going to be equal to 100 times the sine of 24. So I'll write that over here. 100 sine of 24. Times sine of 24 degrees. And we get 40.673, 40.674. This is a pretty high ramp, 40 feet. Okay, let's try another one. Okay, same scenario. We've got a biker thinking about going up a ramp. Or actually, let's say this time he's trying to build a ramp, and he knows he wants this one to be 20 feet high, and he wants the angle of elevation on this ramp to be 35 degrees. So he wants to know how long that will make the ramp. He's got to figure out how much wood he needs to build it. Okay, so again, this is the opposite that we have. This is the hypotenuse that we want to find. So opposite and hypotenuse are related by sine. So we do sine of 35 degrees is equal to the opposite, 20, over the hypotenuse, x. Alright, this is the first one we've had so far where the x turned out to be on the bottom. So you have to work a little harder to get it by itself here. We don't want to solve for x while it's in the bottom, so let's get it out of the bottom by multiplying both sides by x. So I get x times the sine of 35 degrees equals 20. Again, I'm trying to get x by itself, so let's divide both sides by sine of 35 degrees. So we get that x is equal to 20 over sine of 35 degrees. And this is what we can plug in the calculator. 20 divided by the sine of 35 degrees. We get 34.869. So the length of this ramp would be 34.869 feet. Okay, we've figured out the sides in the last three examples by using trig. So now we're going to use it to figure out an angle. So here we have a person. We'll just assume it's the building scenario again. Why not? He knows the building is 21 meters high. He knows he's 25 meters away from the building. I'm going to put this here since it doesn't exactly look like a right angle. But he wants to know what the angle of elevation is from him to the top of the building. Maybe he's planning a zip line and wants to know how steep it will be, or is going to put a ladder up against the building. Who knows? So we've got to figure out what sides we have. We have the adjacent side, and we have the opposite side. So opposite and adjacent are related by tangent. So here's what I do. I set up tangent of theta, because I don't know what the angle is, of opposite over adjacent. Okay? So tangent of theta is equal to 21 over 25. And if you watch the previous video, you know how to do this in your calculator. You know to get rid of that tangent, we have to do the arctangent, or the inverse tangent, of both sides. That's the tangent of -1 you see in your calculator, just above the real tangent, or the regular tangent. Okay, so the tangent -1 and the tangent cancel each other out, and you get theta equals tangent to the -1 of 21 over 25. Like I said, the calculator can do this. So we do second tangent of 21 over 25. And we get 40.030. So this angle is 40.030 degrees. And that will work whether you're in degrees or radians. You just got to make sure you know which mode you're in so you know which answer it's giving, because it can give answers in both. So here we had to use the arctangent, or the inverse tangent, tangent -1, to solve for the angle instead of a side. Okay, I have one more example. Maybe two. I'm not sure. Anyway, let's say this is the flag that was planted on the moon, 6 feet high, and there's a Martian ant who is traveling to the moon, and he is now on the surface of the moon, and he is 7 feet away from the bottom of the flagpole, and he knows the flagpole is 6 feet high, and he wants to know what the angle of elevation is from his eye, or eyes, to the flagpole. Okay, so let's figure this out. It looks like, again, we have the opposite side and the adjacent side. Opposite and adjacent are tangent, so we'll do tangent of theta is equal to the opposite over the adjacent. So to get rid of the tangent, we do arctangent of both sides. That leaves us with this, and we're ready to plug it in our calculator. So we get second tangent of 6 over 7. We get 40.601. So a similar angle, interestingly. So an angle of 40.601 degrees. Okay, that should do it. If you want some practice problems, then I would encourage you to look on page 467 and 468, 49 through 70.